Good morning. Hope you're having a great Friday. We are going to go over balancing equations practice worksheet today. There's also going to be a Prezi presentation that the sub is going to possibly show you after we get done going through this on chemical bonding. So we're going to look first at balancing equations. We talked a little bit about this yesterday. The only thing you can change when you balance an equation is the coefficient. And remember, when we talk about a coefficient, we're talking about the number in front of the formula. Just like in math, it's the number in front of the variable. In science, it's the number in front of the formula. If there is no number written, it's understood to be a 1. The coefficient is understood to be a 1. So coefficients are the only things that we can change in balancing an equation. Remember, we must balance an equation because the law of conservation of mass says that you have to have the same number of atoms on either side of the yield sign. So let's look at a few examples here. I'm going to let you read through parts A and B and do parts A and B on your own. And then we're going to do a couple of examples of part C. All right, let's do the first one first. You may already have this one done because in some of my classes I worked this one out yesterday. But let's review over it again. So if I'm looking at this, I see that I have 1 phosphorus over here and I have 4 phosphoruses on the right side, the product side. Remember, products are always on the right. And reactants are on the left. Then we have 2 oxygens on this side, 10 on this side. I need to get the same number on both sides. I can't take away any of these that are on the right-hand side. All I can do is multiply or put coefficients on the left-hand side. So if I have 1 and I want to get 4, I'm going to put a coefficient of 4 here because 4 times 1 is 4. If I have 2 and I want to get 10, I'm going to put a coefficient of 5 because 5 times 2 is 10. Once I have the same number on both sides, then I'm finished with my equation. I have it balanced. Okay. I did a couple of these other shorter ones as examples in class yesterday, so I'm going to skip down to this big one here. You do the same thing regardless of how big or long the equation happens to be. So here I have one barium, I have 2 chlorines, I have 2 hydrogens, 1 sulfur, 1 sulfur, and 4 oxygens. On this side I have 1 barium, 1 chlorine, 1 hydrogen, 1 sulfur, and 4 oxygens. Okay, so I need to balance my chlorines and my hydrogens. It looks like everything else is balanced. So if I have 2 hydrogens here, the only way to get 2 on this side is to think what times 1 gives me 2, and that would be 2. So that coefficient goes with the hydrogen that it's directly in front of, but it also goes with the chlorine, because the coefficient goes with everything that is behind it. So that's 2 chlorines. If I go back and I check my list and look and see if there's anything balanced now. So my bariums are balanced, my chlorines, my hydrogens, my sulfurs, and my oxygens. So that's it. That's all I had to do is put a coefficient of 2 in the front of that one. So it looked like it was going to be much harder than it turned out to be. Okay, let's try the next page. All right, let's see, which one do we want to do? I think I'm going to try this challenge one because most of these others are fairly simple. I'm going to try this challenge problem. Same concept. I'm going to need to make a list of all of my elements. So carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Please note that in these on the back, I do not have the list written for you. You will need to write your own list of elements, just like I've done here. On this side I have 2 carbons, I have 6 hydrogens, and I have 2 oxygens. Over here I have 1 carbon, I have 2 hydrogens, and I have 1, 2, 3 oxygens. Now, generally I like to balance the oxygens last because they're usually the hardest things to balance. So let's go through and try and balance our carbons first. If I have 2 on this side, what times 1 will give me 2 on the product side? Remember, these are my products, these are my reactants. So I'm going to put a 2 right here. Nope, I'm going to put a 2 right there. That's not my equation. So 2 times 1 is 2. But when I put that coefficient of 2 there, it multiplies the carbon by 2, but it also multiplies the oxygen by 2. So now I have 2 times 2, which is 4, plus 1, which is 5 oxygens. Okay? So now let's think about how can I balance my hydrogens. I have 6 here, so I will need to get 6 on the product side. 2 times what number equals 6? And that would be 3. So I put a coefficient of 3. 3 times 2 is 6. But I've got to go back. I've messed up my oxygens again because the 3 goes with the H, but it also goes with the O. So now I have 2 times 2, which is 4. 3 times 1, which is 3. 4 plus 3 is 7. I have 7 oxygens on this side, 6 hydrogens, 2 carbons. Over here, I have 2 carbons, 6 hydrogens, and 2 oxygens. Is there a number that we can multiply by a whole number? Because it has to be a whole number, can't be a fraction. Is there a number I can multiply by 2 and get 7? There's not a whole number. But I can find a least common multiple of 2 and 7, which would be 14. So if I could get 14 on both sides, then that would be equal. So I'm almost going to have to start over, okay? Because, yeah, I'm going to need to start over here. So I want to put 14 right here. So what times 2 on the left-hand side, what times 2 gives me 14? And it is 7. So that puts 14 right there. Now I need to figure out, if I have 7 and I want 14, I'm going to need to double this. Whatever I have on this side, I need to double it. So I'm going to have to go back, and I'm going to write this in blue so you can see that I doubled it. And I'm going to have to go back and double the 2, which would give me 4. I double the 3, which would give me 6. Now let's go back and recount, because I've changed a whole lot of things. Let's go back and recount and see what we have. 4 times 1 is 4. 4 times 2 is 8 on that side, 8 oxygens there, plus 6 oxygens here, 6 oxygens there. So 6 plus 8 is 14. 6 times 2, though, is not 6. 6 times 2 is 12. So on the product side, I have 14 carbons, 12 hydrogens, and 14 oxygens. On the reactant side, though, I have 2 carbons, 6 hydrogens, and 14 oxygens. So I'm going to have to go back and change my carbon and my hydrogen again. If I have 2 on this side and I want to get 4, the way I'm going to do that is I'm going to put a coefficient of 2 in the front. 2 times 2 is 4. 2 times 6 is 12. And then I already have the 14 oxygens. So let me clean this up a little bit. Like I said, when you're doing these, you really want to use a pencil. Be a lot of erasing. So this is going to be 4, and this is going to be 6. Okay? So it's a lot of trial and error. There's no real rule for how to do it other than you cannot change the subscripts. The small numbers at the bottom, so they're written correctly, and they are written correctly, then you cannot change those. All you can do is put a coefficient in front, and it must go in front of the compound. It cannot go in between. It can't go at the back. It has to go at the front. That's pretty much it. And finish this worksheet in class and turn it in at the end of class. And then if there's time left, you need to view the presentation on chemical bonding. All right, have a great day. Bye.